I want to know, can someone raise their hand and tell me what the difference between ARC and IRC is? Can someone raise their hand? Go ahead.
The average rate of change, ARC is like the average rate of change, and it's between 2 points. It's like the slope of the secant line between 2 points.
Okay.
And then the IRC is the slope of the tangent line at a single point.
Okay, so the average over a period of time versus a speed or a velocity like at an instant in time, right? Okay. So this handout here I have is, I collected some, it's not organized very well, but I collected some different things I thought would help us as we just prepare for word problems for next time, okay? So what I want you to do is I want you to go to the side that has the it says instantaneous versus average rate of change on the right. You see that? Okay. So there's 6 questions there that ask you to take the way that is phrased and decide if it's asking for average rate of change or instantaneous rate of change. So I want you guys to work on that with your neighbors. Okay? So the 6 questions that have you decide if the phrasing is about ARC or IRC. That's what you guys should be working on with your neighbors right now.
Yeah, so that would be.
Daniel, do you have homework for me to stand? Daniel, can you put your phone away?
He makes this voice that sounds like Barry from High Chance of Meatballs.
I haven't seen that movie.
Me neither. And he keeps talking about it every single time. He.
And then do you have homework for me to stand?
Yeah.
Okay.
It's all opposite.
Okay, let's come back. Can someone raise their hand and tell me what they think 1 is and why?
Average.
Why?
Because it's from point t equals 2 to point t equals 2.
Okay, do you guys agree?
Yes.
Okay, so then how would I find it?
It's the points. It like subtracts and then you do like a weird thing.
I'm hearing lots of talking. Can I get a hand raised? Oh, now nobody wants to answer. Oh, yeah, go ahead. Yeah, f of 5 minus f of 2 over 5 minus 2, right?
Yeah.
With me? Average rate of change, slope. So to find that, I agree, it's average rate of change, and you would have done f of 5 minus f of 2 over 5 minus 2. Good. Okay, next one. Someone new. Someone new. Next one. Go ahead. Why? Okay, I agree. So then how would I find it? So then how would I find it? Nope. So then how would I find it?
I don't know, Caleb's pretty smart. He seemed to have said something.
Find the derivative and then do what with it? Well, you are, but how do I find the slope of the tangent line? What do I do once I find the derivative? So how do I do that? What do I do? Plug in 3. F prime of 3. We got it? Questions? Okay. Number 3. Which one is it? Why? Okay. So then how would I find it? f prime of noon. I don't know. Whatever number you decide noon is, it depends on what you decide 0 is, right? Okay. What about number 4?
Average.
Average. So then to find it, I would do f of 5 minus f of 0 over 5 minus 0. Okay, what about number 5?
Average.
Average, good. So f of 12 minus f of 0 over 12 minus 0. And then number 6? Good, instantaneous. So f prime of 7, okay? Now I want you to talk about this with your neighbors for a second, okay? I want you to tell me what is the difference between the units of measure between ARC and IRC. Do I need to say the question again, or do you understand?
Say it again.
Hey, what's the difference between the units of measure used when I'm finding ARC versus when I'm finding IRC? Go.
It's like if it's average rate of change, it's the same. Because the whole reason why I changed the unit. No, I'm not. You're wrong. You're tight now.
Alright, so.
No, it's because what you're saying is like hours measuring time. So we're measuring
Okay, come back. What do you think? Anyone have any thoughts? What's the difference between units of measure used when I have ARC versus IRC? What's the difference? Nobody has a thought? Yeah.
So like instead of like being some amount of time per 1 minute, it's like per like several, I guess. I don't know, it's not a unit.
Nope. That's a good guess, though. Good thought. Do you guys want more time to talk?
Does it have something to do with that thing?
That's how I'm going to explain it.
Okay.
Yeah. Once we get it. You want another 30 seconds? Another 20 seconds?
Sure.
Okay, take it. That means talk to each other. You guys all telepaths? Anna's not here to make you talk today? Oh, okay.
So nervous. What's the question? It wasn't it the difference between the units between
ARC, ARC and ARC, yes.
There is one, for example.
Okay, come back. What do you think? Come back, what do you think? Come back, come back. What do you think?
Is like more general.
What, Colin?
There isn't a difference.
Agreed. There is no difference. Right? Good. Aren't they both finding, hey guys, aren't they both finding a slope of a position versus time graph, right? They're both finding the change in y over the change in x. Look. One of them is finding a slope here, and one of them is finding a slope here. Right? But it's the same graph that I'm finding the change in y over the change in x. Does that make sense? So for both of these, my units of measure would be feet per minute, right? Now the difference comes in when I'm finding, basically the idea is one of them is finding the average rate of change, the average derivative, right? The other one's finding an instantaneous rate of change, an instant derivative. But they're still both the first derivative. You with me? So where the units is going to change is when I derive again, right? If I found the acceleration, then I would have a feet per minute squared, or feet per minute, same thing, right? You guys with me? Okay, So now what I want you to do is I want you to, there's 2 more things I want you to do. Just to make sure, again, like the whole point of today is prepping for some word problems we're doing next time, making sure we understand the slight differences and how things are worded and how it applies to what we've done so far this year. You guys, everybody with me? Okay, so I want you to complete the table and do the matching. I'm going to give you 2 minutes and then we'll go over them.
This left side.
Yeah, but at the table at the bottom of the right side and the matching on the left side, okay? No, other side. Yeah, so you're gonna do this table and this matching. Okay, you've got 2 minutes. Okay, just to make sure we really understand this word problem stuff and how it relates to what we've been doing.
Matching this stuff up and then doing this table. I mean, 6 is E.
Instantaneous rate of change is rate of velocity.
Yes.
Instantaneous change of velocity.
It's in velocity.
Oh, it,
Okay,
not
so number
reading
5
a
is
sentence. Number 1 is A. Because velocity is the change of position. A is the change of position. Acceleration is the rate of change. Also, acceleration. And then just the gallons, like meters per second. I think it's meters per second per second. Yeah, the bow is that percentage instantaneous rate of change of velocity. Or no. Position is gallons per hour. Units for instantaneous rate of change is volume. Yeah, gallons. 3 is G. Acceleration, I think, is meters per second. Acceleration is 7 Oh, this, yeah, I think it's, this one, hey, ball, this ball on the table. We're doing this part? We're doing that one. And,
What'd you get for like?
Oh, just the one.
I'm not just the one on the table. Like your answer down the bar. Where did she go? I don't know.
That's what I thought it was. What do you mean throw knife? I didn't answer it.
Maybe you probably do just do it anyway.
2 is F. 3 is AF.
What is it, centimeters? Oh wait, 3. 3 is C. Sorry. 3 is C. It's gallons per hour.
7 is C.
Wait.
This one, there are gallons per hour.
Bored today. Tired.
Oh wait, no, it's the other one. 3 is G.
We paired your cards last night, so I was feeling
Oh, I didn't see that one.
And I have a 45-minute drive home, so I got home around 9. Because I have to get my daughter ready too. But it's all worth it to help shape the youth of tomorrow. Right? Hey, can I have somebody come put the first units of measure on the board? the first units of measure on the board? Look like you're considering. Go ahead. Second units of measure on the board? Second units of measure on the board? Yeah. Will you do the third units of measure on the board? For the bottom right table.
I'm gonna just keep it.
Well, I don't even give you one. The second one out of the three you're gonna do. Okay, we all gotta get used to it eventually. Starting real soon. To be honest, you're like I haven't done it already, but I normally get out my random number generator when I want questions and stuff on the board. Phone pocket number 15. Phone pocket number 9.
Call mine.
Good? You guys agree? Yeah?
I'm confused on their one.
Bottom right table.
I thought it was second.
Isn't it centimeters per second per second? Or is
Oh, yeah,
the
it is
same
in
thing?
seconds.
Centimeters squared per.
It's in seconds.
It's in seconds? Okay.
But wouldn't it be, centimeters per second?
Right, for 18.
But we're taking the first rotation.
Good?
Yeah. Oh wait, isn't it cubed?
Is it cubed?
Yeah, it's cubic meters. Wow. That one's good.
That one's good. Is there another way to write this one?
Yeah.
Both are perfectly acceptable. Okay. Good? Okay, let's look at the matching. Just to make sure, again, you guys agree, right? Like when I was doing the one earlier today, all I did to totally change the problem and what screwed Miss Summers up is I covered up one word, IF, right? If? All these I words, right? Okay, but the reason that I'm doing this today with you guys is the subtly way it's written in the question totally changes what it's asking. So hopefully this is starting to seem easier as we do this matching and stuff like that, because I'm trying to get you to realize how these problems we're going to be doing next time, because today again is more of a vocab day, are relating exactly to what we've done before, right? Okay, so is anyone confident could raise their hand and just tell me the order of the letters they got on the matching?
A, F, G, O, H.
Spencer, you already answered one today. Go ahead, Kate.
I did A, F, G, D, B, E, C.
Perfect. Good? Okay. You guys can go ahead and put, we're going to do the other side of this handout probably maybe next time, I don't know. But we're going to do something different now. Okay.
What if it's not even on the side? Oh, no.
Yeah, this is our notes.
Changed my question. I can't write anything down. She always changes it. Keep going.
Okay. Hey, you guys were a little distracted today. Everybody with me? You got it written down? We're ready to go? Okay, we're going to be using this problem for the next, half an hour. So, yeah, we're going to talk a lot about it. Again, hopefully today it's easier than last time for sure, right? But the idea is that we're trying to see how what we've been doing so far this year relates to this type of stuff, these word problems and context, okay? Okay, so can someone tell me what the idea is here? How would I find this? Got it. P of 2. Find it. No calculator. No way. Even to do the addition? Yeah. Do you think on the recording they thought that was a different person? Was my voice changed so good? Yeah. Oh, my bad. It's almost like I did that on purpose. Hey, what'd you get?
I'm so writing. You said not to write anything down. Don't write
I said that one time last
And
lesson.
now I have to apply that to everything because you crazy.
Anybody get it yet? We have to just answer.
4 times 3.
The answer is 8.
Nope.
Wait,
The
what?
answer is not 8.
Yes.
Nope.
Right, the answer is not 8.
Did we do it?
Nope. Closer though. Nope. Closer though. 8 feet. There we go.
Okay,
Oh, I was worried I got that wrong.
What is it?
Well, I assumed you're 8 miles.
Well,
No,
you
stupid.
I assumed your 8 meant 8 miles, but now I know it meant 8 feet, right? Rule of thumb. If they give you a unit, you give them back a unit, okay?
On campus, they never like put units, otherwise you get it wrong.
On canvas?
Yeah. Do we use Kansas?
Yeah.
Well, that's gonna.
Why did you say that?
Really?
Yeah, that's weird.
No, you have to put units at everything. It's probably because your teachers are probably making the quiz themselves, and there's too many options. Like if you put in FEET or FT or FT period, and they probably just don't want to write all those out. But okay, are we doing good? Okay, next one. What do I do? Take the derivative. How many derivatives? And then what? Find, okay, so find the derivative and I'm done.
Then you plug in 2.
Then you plug in 2.
This reminds me of
Oh yeah. Can someone go write it out? Can I have someone come work it out on the board?
I understand what I wrote for some reason.
plus 19 loss, where it should just disregard
How are we doing?
Oh, wait, no, hold on.
Let's go.
Wait a second.
How fast is that in kilometers per hour?
What? Yeah.
I just simplify and that too.
What do you think?
You can't have a negative velocity.
You can't have a negative velocity?
Actually, you can't.
Ah, there we go. So remember, velocity is a vector. What that means is it has a direction attached to it, right? All this means is that that's my speed, right? That's how fast I'm going, but this particle would be moving left. You could say left or backwards. Can't say down though, because it's a horizontal path, but watch that. Does that make sense? We're doing okay? So, hold on, I'm going to ask you two questions. They're going to sound similar, but they're totally different, okay? Is the particle increasing or decreasing at 2 seconds? Decreasing because the velocity is negative, okay? Is the speed of the particle increasing or decreasing at 2 seconds?
Increasing.
We do not have enough information yet. We don't have enough information yet, right? If speed relates to velocity, right? And for me to see if something, the reason I knew that the particle's position itself was decreasing, okay, at 2 seconds is because I know its velocity, I know its derivative, and its derivative is negative, right? But because speed and velocity relate to each other, if I need to know if its speed is increasing or decreasing, I need more info. I need to know something about the acceleration. You with me? Okay, go ahead.
On this one though, wouldn't it be the same speed because it's moving along the horizontal line?
No, because it could be going like, right? We don't know if it's doing the same speed. Well, yeah, I mean, does that not make sense?
It's just funny that you.
It's not a constant speed necessarily because it's on a horizontal line, right? I'll do it again here for them. Like maybe it goes slow and then it speeds up, right? Like we don't know how fast it's moving or when, okay? I liked my hand display there, Colin, hater. Okay, now hold on. Let's talk about speed for a minute. What is speed? How is it different from velocity? What's the difference? Yeah.
It's how your velocity changes over time.
How my velocity changes over time, okay? So add to that. What else? It's not the acceleration. Huh? Come on. What's the difference between the two?
Speed is not a vector.
Okay, so if speed is not a vector, what does that mean? Doesn't have a direction. What does that mean? Doesn't have magnitude. No, it has magnitude. Magnitude is like length. Okay? Keep building on this. We're doing we're class collaborating. That's what we're doing. Keep build. What does that mean? If it doesn't have a direction, tell me something else I can interpret from that.
The negative would mean that it's speeding up or slowing down.
Not necessarily. Not necessarily. We don't know what direction it's going. So what should I take away from velocity if I don't know what direction it's going? I can never have a negative speed. Right? Speed takes the direction out. It still is dealing with how fast something's moving, right? But it's dealing with it, right? Without the direction. So it takes out the negative. So what math operation does that? Good. The absolute value of velocity is the speed. Okay? So here, if I said the speed at t equals 2, right? I'd say it was 15 feet per second. So there's two ways to answer my other question we didn't have enough information to answer yet. When I asked you guys, is the speed increasing or decreasing, right? If this is my velocity equation, then isn't this my speed equation? Right? Is that fair? So I could derive that, but I don't want to. I'm going to do it a different way. Because you guys hate absolute values.
Yeah.
Right? Okay.
You do that dumb thing with limits where you put
Yeah, the dumb thing with limits. Okay.
Yeah.
Now, before I can answer that question about is the speed increasing or decreasing, I need to ask a different question, which is, what is the acceleration at t equals 2? So find that.
So it's just that you got the mean, you're involved, right?
Can someone come work it out that hasn't answered a question or come to the board yet today? You participate all the time. Yeah. Hey, I need somebody who hasn't answered a question or come to the board today to come do this on the board. You've already answered a question. Either Caleb or Taylin or Nate or Daniel.
I already came to the board.
You did? Oh, you did one of the units ones for me. No, you told him to, but he didn't end up doing it. Daniel's got it. Yeah. Daniel's got it for me. I want to do pink.
What if they can't see it on their cameras? That's for them. Stop. I can hear you.
Hey. Yep. That looks like a negative 18.
That is.
Yep, negative 18. Okay. Guys and girls, negative 18 feet per second squared. Do you agree? Yeah? So what's the negative 18 is what it says. Hey guys. Come on. It's an 18. I can see it.
You can see my handwriting.
Okay, can we stop talking about the 13? There we go. Okay. Okay, guys, listen. Again, remember, what we're doing today is trying to relate some of these words to what we've been doing all year, okay? So what's the concavity of the particle's position at time equals 2? What's the concavity of the particle's position at time equals 2?
If it's negative.
Concave down, because my second derivative is negative. Good. Okay? If those aren't coming quick, you need to go back and look at your derivative characteristics table on the front side of your ultralavas. You with me? Now, here's my next question. Is the particle speeding up or slowing down at time equals 2? Nope. It's speeding up. Why? Because they're both negative. I don't get it. So if they're both negative, why could it be speeding up?
Is it because they're both negative?
It is because they're both negative. Let's look. Hold on, let's look. I just want to talk about this for a second, okay? There's 4 basic graph shapes that we deal with, okay? These are our 4 basic graph shapes, okay? Whether it's, and who knows what the slope of those are? Those could be logarithmic, exponential, polynomial, rational, right? Those are the 4 basic shapes besides straight lines, right? That come together to make most of our functions. You with me? Okay?
Yeah.
Which one of these is our situation? Nope. C. Because I have a decreasing concave down, right?
Oh, yeah.
With me? Can I go reverse in my car, but be getting faster and faster and faster in the reverse direction?
Yeah.
That's what's happening, right? What if I was in a car and I forgot to put my e-brake on, right? And I was taking a sweet selfie, but because I forgot to put my e-brake on, I start going backwards down a hill. Right? But am I going to be slowing down as I roll backwards down the hill? No, I'm going to be speeding up. Right? The tricky part is that direction stuff. You guys with me? Okay? In this situation, this concave down decreasing, okay? Well, oh no, here's my next question. I want to know, of those 4, which ones, I'm going to give you some time to talk about this with your neighbors, which ones are speeding up and which ones are slowing down? Okay? Out of those 4, I want to know which ones are speeding up and which ones are slowing down.
A or C or yeah. Slowing down.
What do you think? What do you think? Anyone? What do you think? Okay, Igor says A and C are speeding up, meaning you think B and D are slowing down?
Yeah.
I agree. Here's what we have to be careful. Again, right? If I'm decreasing negative velocity, right? That's taking into account its position, its direction, right? But when I'm dealing with something that's speeding, as soon as I'm dealing with speed, I don't care what direction. The idea of speeding is my tangent line slope getting steeper or less steep? It doesn't matter what direction its steepness is changing in. You with me? Okay? So I agree that these 2 are speeding up. Position is speeding up. And these 2, my position is slowing down. Can I answer that question with only velocity or only acceleration? No. Okay, on this one, is my velocity positive or negative?
Positive.
Is my velocity or acceleration positive or negative?
Positive.
Good. This one, velocity. Acceleration?
Oh wait, yeah, positive.
Okay, concave down, right? Velocity? Ugh.
Velocity is positive.
Ugh. Decreasing?
No.
But acceleration is positive. It's decreasing, the velocity is negative. These slopes have a negative slope.
Oh, I thought it was this. That. Yeah, acceleration. Yeah.
Okay, velocity,
Positive.
acceleration. So find for me a pattern. I want a pattern. Or something you notice.
Same sign as speeding up.
Colin, thank you for raising your hand.
When it's speeding up, they're the same sign. When it's slowing down, they're opposites.
When you say there, I don't understand what
The
that means. You
velocity
mean,
and acceleration.
oh,
That's what he was talking
you agree? I agree. So if my position is speeding up, then my velocity and acceleration have the same sign. And if I'm slowing down, my velocity and acceleration have opposite signs. Yes. Good. Not everybody's in physics, bro. This is new for some people. Hey, everything I have over there looks pretty ultra lava worthy, by the way.
Where's he say this now?
We have a couple more things we're going to talk about, but I'm just going to give you a minute or so to write this on your ultra lava.
For some reason, my brother saw my ultra lava and like got PTSD from the year they did.
My brother still has this. He's like, do you just want mine?
I didn't know I had your older brother, Colin.
Huh?
I didn't know I had your older brother. What was his first name?
It's Cade.
You had my older sister.
Oh, Cade. Huh?
You had my older sister.
Yeah, Hannah, right? I liked Kate too. He just was quieter than Hannah. Hannah wasn't in calculus either. She was she was in calculus. Did I have calculus or sex 2? Do you remember?
It was calculus.
Yeah.
I can see. He's also really tall. Kate is also. No, Kate.
I don't think Spencer's older brother liked the class at all.
No, Nate hated that.
Huh?
Nate's a funky
Yeah, he's the swimmer, right? Spencer, isn't he a swimmer? Yeah, he spent so much time swimming. He's like, I can't ever do calculus.
Oh yeah, that's true. That was really my friend. Nate's
Last name? Or first name, maybe?
Nate's like
I don't know.
Do you remember Kyrie Wilson?
Nate didn't, but he looked younger than he was.
Sister's actually super jealous of you.
Oh yeah, I do that every year. I just did it last year because of COVID. I cook for all my students the right before the test. I'll do it this year.
Oh yeah. And
Last year I was COVID, so I couldn't. But no, did I? I did last year.
last year.
Yeah, 2 years ago was the COVID shutdown, so I couldn't. So instead, I sent out a sweet karaoke of me singing "Shallow" at the top of my lungs in order to make them all laugh. So that was the replacement for breakfast. It's my moment. Yeah. It's probably still on my YouTube channel, to be honest. I never cleaned that out.
Good to know.
Do you guys need more time to write this on your ultra lava?
Yeah, like 2 more minutes.
2 minutes? Not happening. Maybe 30 seconds.
So like the
I
diagram.
just ready to start my paper.
Okay, I'm giving you your next question. Are you ready?
Yeah.
Put everything we've talked about together today, maybe make some new connections too, and answer this question. Is the particle speeding up or slowing down at time t equals 1?
Yes.
Is the particle speeding up or slowing down at time t equals 1?
Slowing down.
If you're already taking that guess, You need to do a little bit more work
It's
first.
50-50.
I don't know, I'm not saying it either way.
It's 50-50, so if you.
I guess our.
Is it 50-50?
It is 30 degrees. What if it's no? No, you're right. So I
It's not 50-50. Nope. Why don't you guys try and go through what we've learned today and see if we can put some connections together.
What if it's just yeah? It's in a horizontal
Straight.
the horizontal line like this.
We gotta find the velocity.
I already know what you did.
What did I do?
What if it's not moving?
I don't know, what do you think?
Then it's not increasing or decreasing.
I don't know, what do you think?
That's what I think. No. Just
Okay, come back. Anyone have a thought on time t equals 1? Daniel? Or Colin? I'm not sure who was raising their hand there.
It's Daniel.
So since the velocity and acceleration both equals 0, then that means it's just not moving at all.
So is it speeding up or slowing down?
Neither.
No.
Neither.
Like I said, everything.
A particle at rest can't be speeding up or slowing down.
Because it's resting.
Yeah. good
What
enough.
is the particle speeding up or slowing down at time t equals 1? The problem is, when I plug 1 into the derivative, I get 0. So if this velocity or how fast the particle's moving is 0, the particle's at rest. It's not moving. Can't be speeding up or slowing down, right? You gotta be careful though, because in this case, both were 0, right? But I can have situations where the velocity is 0, but it still has an acceleration. I want you to think of like gravity, okay? If I take my pen here, I'm gonna try, right? Okay? At the very top of the arc, it's not moving,
Yeah.
but it still has an acceleration pulling it down. Does that make sense? But it still is a point of rest at the top of the arc, right? If this here is 0, then that tells me something about the particle. It's taking a break, right?
It just decided to stop.
Maybe.
Like after 5 minutes,
Right?
it disappeared for a minute.
Yeah, right? You guys doing all right? Okay, so we're going to stop for a second here, and we're going to talk about that for a minute. So let's say this graph has nothing to do with this situation, okay? This is just some other graph. It's a velocity graph. We'll start it at 0. Okay, careful, this is a velocity graph, right? How many times does this particle take a break? 3. How many times is that break also a direction change? Nope. 2? Why? Still going the same direction on the third one. It just takes a break, like a red light in a car,
It just kind of slows down and stops.
right? With me? Now I want you to relate those ideas to what we talked about like a month ago. Derivative characteristics table, derivative sketching. The direction change of the particle, the at rest at the particle without a direction change, what does that relate in our derivative sketching? I want you to realize that a lot of these concepts we're going to be doing in these word problems are the things we've already spent a ton of time doing. That's the point of the lesson today, right? So how does that relate to what we did in derivative sketching? Help me make the connection. What's the direction change like? What's the at rest without the direction change like? What do you think? Anyone? If you ask me what the question is again, I'm gonna smack you. I'm gonna lose it. Should we do an instant replay?
Yeah.
Anything that relates,
Anything that relates.
because like, so for like the particle would be our resting point, like the relative max of it.
Good. The direction change is our relative max and mins. Perfect. Right? Is that good? So then what's this one? The at rest without a direction change. What's that like for us?
For the velocity graph?
No, for the original graph.
The original graph?
You guys need to go back and look at your derivative sketching table before next lesson.
It's a horizontal.
Horizontal, tangent, point of inflection, right?
I can read.
Okay, we're doing good? Okay, what questions do you have before we talk about our last two vocab words for today? We're good? Any questions? My question, and it's not a question, it's a statement, is I think a lot of you need to go back and look at your derivative characteristics table. Big time. Okay,
Oh, my
now, two other things. Two more vocab and then we're done. Homework tonight is going to be like last time, so it's going to be more mean value theorem FRQs, okay? And then on Monday, we're going to be doing more FRQs related to this stuff. Just, I'm just hoping so that you guys can realize maybe the words look different, but it's all the same basic derivative rules we've been doing. Good? Okay, so two things. The first one is displacement, okay? So let's say I was gonna go to my friend's house, okay? I'm right here, all right? My friend's house is 6 blocks away. So I make it halfway there, right? Man, I forgot my coloring book. Okay, so I go back. What's my displacement right now?
0.
What's displacement?
It's how far away you are from your starting point.
How far away you are from your starting point, okay? What's the difference between that and total distance traveled?
The total distance traveled is how far you went there and back.
Okay. Think of it like a pedometer. I'm getting my steps in. I'm trying to win a race against other maybe teachers, right? Do I want my pedometer to show my total distance traveled or my displacement? Yeah, I'd be pissed if it showed my displacement, right?
Like 0.
What would my total distance traveled be right now?
12?
Nope.
No, it would be like, what'd you
6.
say? 6.
I waited halfway there, I made it back, right? Good? Okay, so now I got my coloring book, so now I'm at my friend's house 6 blocks away. What's my total distance traveled? 12. What's my displacement? What's my ending position? 6. What's the difference between displacement and ending position, or is there one? When you say everything into account, what do you mean? Kind of, yeah, kind of. What else? What's the difference between displacement and ending position? In this case, were they the same?
Yes.
Are they always the same?
No.
Why not? What would make it so that they're not the same?
If you didn't move in straight line.
Nope.
If you started like beyond 0 or something.
They're only the same when you start at 0. Good. Position is a single point. Okay? Displacement is like a length, right? I want you to look at this one here. Do I know where this particle started? Yeah. 10. At time equals 0, I can put the zeros in, it's 10, right? Okay? The ending position at time equals 2 of this particle is 8. What's the displacement of the particle at 2 seconds? -2. Right? Because I went back 2 from where I started. The idea of the displacement is it's how far, right? Think of it more like a length, how far I am from my starting, where the ending position is more like starting position plus my displacement, right? Where I start plus how far I went is where I end. Does that make sense? You guys with me? Okay. And total distance traveled takes into account all movement. Good? We're doing good? Okay, last vocab word for today, and this one is an ultra lava one, is critical values. Now, in previous math classes, your teachers have used this word critical values to mean any important point, right? X-intercepts, Y-intercept, max, min, you with me, right? But now critical values, for the rest of the year, that vocab word only has one meaning. It's anywhere the derivative is 0 or undefined. Good? So no longer about if it is x-intercept, y-intercept, it's if it's 0 or undefined. We're doing good? Okay. Again, homework tonight is more FRQ work. They're released FRQs again, so you can Google them. Dealing with MVT and IVT, okay? And then if you don't feel comfortable with your derivative characteristics table, make sure you look at it before next time, where we put this kind of vocab discussion with what we've been doing this year and try some more words in FRQ.